What are some unreasonably fragile parts of the human body? First of all, there are the male testicles, densely packed with nerves extremely sensitive to touch and pressure, and even a light blow can cause excruciating pain. On top of that, it comes with a fear buff that inflicts significant psychological distress. Except for a few ruthless individuals who think these things are useless and just get rid of them to give to others, for most people, they are extremely precious. Yet, despite being such an important organ, the testicles hang independently outside the body with no protection whatsoever, which is really unreasonable. Of course, the genes were forced to design it this way. Back when we were still fish in the sea, the primitive organs that would become testicles were securely protected inside the body, even close to the heart. Later, we came to land and evolved into warm-blooded animals with body temperature at 37 degrees. Human sperm survive best at 35 degrees. If testicles stay in the body, germ cells are inactivated by heat. How can they reproduce? So they descended to hang outside the body to cool. We mentioned this before, and part of evolution repeats in embryo development. Early in embryonic development, testicles are in the abdomen, then descend outside. However, this brings a problem. If testicles descend, the vas deferens must also elongate. This causes the male vas deferens to be different from what we talked about before. My recurrent laryngeal nerve is the same might takes a long, unnecessary detour. Next is the temple, located at the junction of the frontal, parietal, temporal, and sphenoid bones, with a large number of blood vessels and nerves running underneath. The key point is that while the thickness of most other parts of the skull is about 5 millimeters, the temple is less than 2 millimeters thick. So even a light blow here is enough to instantly take down a man weighing over 200 pounds. In mild cases, you need medical attention. In severe cases, it's basically the human body's one-touch shutdown switch. As for why the genes designed it this way, it was also out of necessity. They never expected that humans would one day grow such big heads. When our brain capacity was still small, the thickness of the skull at the temple was about the same as in other areas. But as the human brain expanded, the skull expanded along with it, so you'd think the temple would expand too. Sorry, it can't expand at all. The temple is anchored by the jaw muscles. If you want it to expand, that would only be possible if humans stopped opening their mouths, so the temple can only get thinner and thinner. And if we're talking about the biggest and most obvious weak point of the human body, it's the neck. The neck connects the head and the torso, serving as a crucial link between them. The inside of the neck is very complex central nerves, trachea, esophagus, and major arteries all pass through. Elsewhere, a fracture usually just means a broken bone, but a neck fracture is life or death, and there's no protection. That's why, since ancient times, choking and throat locks have been deadly, and in combat sports, the rear naked choke works by compressing the carotid arteries, cutting off blood to the brain, and causing unconsciousness. The carotid sinus is also in the neck. It senses changes in blood pressure and helps regulate heart rate. There are a large number of nerve endings distributed here, so if excessive external pressure is applied, it can cause fainting, even kissing. If someone kisses this area, it's possible to pass out. So guys, be careful when making out with your girlfriend. Of course, if you don't have a girlfriend, there's nothing to worry about. Actually, it's not just humanity, the animal in nature that has a neck, without exception, has the neck as its weak point. Lions and tigers always go for the neck first when hunting, and even giraffes attack each other's necks when they fight. It's truly a form of free combat, however. Human necks are different from those of animals we walk upright, so our necks constantly have to support our heads. Back in ancient times, when everyone was a hunter, this wasn't a problem. But our genes never anticipated that humans would one day invent computers and smartphones, and that modern workers would spend long hours looking down at screens. As a result, the muscles at the back of the neck have to stay tense to maintain this downward posture, causing the muscles in the neck and shoulders to become stiff. For example, the splenius capitis, the levator scapulae, and especially the sternocleidomastoid muscles, which directly connect the thoracic cage, shoulder girdle, and head. When these muscles become stiff and deformed, the head's weight compresses blood vessels and nerves. If blood vessels are compressed, the brain doesn't get enough blood, causing fatigue. If nerves are compressed, your neck is sore, stiff, or cracked. The back of the head houses the cerebellum and brainstem. The brainstem regulates basic life functions like breathing and heartbeat. Although the skull at the back of the head is thicker than at the temples, it's still not very thick. Pressing on this area would make even the legendary physician Bian shake his head and sigh. Even the UFC, known for no-holds-barred fighting, explicitly forbids strikes to the back of the head, showing how vulnerable it is. Among internal organs, the most fragile is the spleen. The spleen is the body's largest immune organ and also produces blood. It's dark red, soft, and resembles half-cooked duck blood. If you put spleen slices in a hot pot, they're just like duck blood. If you cook them a moment too long, they'll fall apart. But the spleen's location is awkward, just below the 9th to 11th ribs, so the ribs provide some protection. Its protection is limited, and even a slight impact can rupture the spleen. So, everyone should be careful not to strike the body violently. What do these seemingly unreasonable weaknesses tell us? They show that evolution isn't about perfection, but about making do with what works. If a segment of genetic code doesn't work well, what do? Just write another segment to patch it up as long as the program runs. That's enough. After millions of years, isn't it inevitable it turns into spaghetti code?